And today's session is fully dedicated to Laplace transformation. I'm sure that many of you have already done it, but I think it is the time to revise it today, and then on Thursday, I will be there in person class. We will start the control systems. So let me share with you how many people actually know Laplace transformation properly. Just raise your hand so I can see you on the screen. So only Nick is there. Nick is there. Skylar knows. Anybody else? Bella, Zach.
Tyler Lee, Yee.
Okay, all right.
Think that's hand raising.
So, yeah, you see only Scott.
Yeah. Yeah, I couldn't find the hand emoticon.
Yeah, okay. So there are a couple of people who are saying, but they are really less than 5%. So it is good to look at this transformation little bit, deeply, so that you can use it for the system. What we will analyze using our, control theories. So let me share with you my. Let me share with you my OneNote, and here the first thing I will do is to give you a very basic uh, definition of Laplace, and that is where we will start. So if anybody knows what is the basic definition, if I say find the Laplace of a function, what you will do. So basically uh, you need to find out if this is you have to evaluate the integral for that, and the integral for that is given by the following equation. I give you the basic. Here is the Laplace of a function. If you have been given a function in domain time t, and you want to transform it into domain S, then this is basically your basic equation that you will use for the conversion. So it is a transformation from one domain to the other domain, from the time domain to S domain. You will see that in S domain we will get all sort of algebraic equations, and you can manipulate them, and then you can come back, you can solve them, and the final solution can be done by taking the inverse Laplace. So then you can bring the solution in terms of time domain. So it's an easy way really to solve the equations. First of all, convert them into time domain and then solve it, and then the final solution is then brought back to time domain by taking the inverse Laplace. So there are two steps which are involved. One is basically the Laplace. You take the Laplace of a function which is in time, and then as a function of time, and then you convert, you solve it, you do whatever you want to do, simplify it, or whatever is the goal, and then you bring the final answer by taking the inverse Laplace and bring it into time domain. Now you must know how to do integration properly. If your integration is weak, then you have to practice a little bit more. Let me tell you the first example, and I want everybody to see that what they will do. Let's assume that you have let me solve some problems for you so that you can understand how to really solve these things properly. Should be a nice example here. So let's solve this. Show that you find out the Laplace of 1. So let's try with the simplest one, and I will just say as example 1, and I will say, can you find out the Laplace of 1, please? So all you have to do is you need to solve the above integral by putting ft as 1. So tell me what you get. So please solve it and tell me. Skylar, what you will get? So you will get,
Something like 1 over s.
how will you get it? So you will
But
get 0 to infinity, right? And then you will put e power minus st, ft is 1. So all you have is the integral of 0 to infinity e power minus st. Now, what is the integral? What is the integral of e power st? So remember that you can simplify this thing by assuming that you can simplify this thing by assuming ft is equal to 1. So you get 0 to infinity e power minus st 1 dt is 0 to p, where limit is p tends to infinity e power minus st. Now you solve this integral. As I said, that the solution of integral is very important. So you solve this integral, and then you apply the limit. So when you will solve this equation, you will get the final solution, and the solution for the equation will be then given by this thing. So you will have Laplace of 1 will be ft is 1, then you will get e power minus st. Of course, the integral of ex is ex. So you get, e minus st integral is e minus st divided by what is the derivative of the power with respect to time, with respect to t. That will be minus s. So you divide it by minus s. So then you get here, you put the value of 0 and p. When you put the value of 0, you will get e power 0 is 1 minus the lower one, and the upper one minus lower one, because this is a minus sign, that will change the order on in the denominator. So you will get 1 minus e power minus pt over s. Now, what happened to this term? Why it is 1 over s? Why it is 1 over s?
as e raised to the negative infinite power approaches 0.
Why? How? So e power minus infinity is basically 1 over e power infinity, and e power infinity is infinite. So 1 over infinity is equal to 0. So you have to see that how you apply the limit. Now there will be some functions in which they will be sort of a indeterminate form. If you apply a limit and it becomes not you don't get 0 or 1 or anything, what you do, what rule you apply? What rule you apply if this limit is you substitute this limit and is substituted and you are getting indeterminate forms? What you should do then? There is a way to do it. What is that? What is that technique is called?
I got no idea.
Is
Okay.
it L'Hopital's rule?
Yeah. So let me copy the image for you. So in case I will say that when we apply the limit and we do not get any answer, which simply means that it is a indeterminate form. Then we use the following method. What method we use? So that method is given by this image. Oh, where that image is gone? I'm sorry. Okay, so that never came. Okay, hold on. So then you should be able to hold on. So you should be able to get the limits, and I will give you the answer in a minute. Just give me this one. So here is the rule which you should apply. Here, and this is a very nice example which is given here. I will just copy it here for you so that you here. So then we apply this L'Hopital rule, and according to this rule, if you have functions in which when x tends to c does not give us any answer, then what you do, you take the top and bottom, you take the derivatives of that, and then you apply the limit. One example is given here, which is really good example. Look at this example. Here it is saying the limit x log x. So you will go here, log x over x minus 1. Now, of course, if you put x is equal to 0, 0 into infinity is not a really any indeterminate form. Then what you do, you take x into numerator and denominator, you separate them, and then you take the derivatives of them. So L log x derivative is 1 over x, and x minus 1 derivative is minus x minus 2. And now you simplify it and you get minus x, and when you put x tends to 0, you really get 0. So L'Hopital rule is really applicable in our case whenever and it's used a lot when you try to apply the Laplace on some functions. Let me give you another example, and that will help you as well to understand what is basically your here. So now try this equation. Try this equation. All right. So everybody should do that here. So what is the Laplace of t? So please find out. Laplace of t, please do your calculations and see if you can do it. So of course, Laplace of t is your ft is now t. Before ft was 1. Now you have to put ft is equal to t and solve the integral. So please solve the integral. Please solve it and see what you get. So what is the answer? So you should tell me. Where is this guy? Hold on. I'm looking for one guy. He should help us. Okay, please do this quickly. Scott, can you help us to do it?
I'm still kind of going through it.
Okay, thank you.
Is it just T over S?
So there should not be any T anymore.
Oh,
When
I'm
you
sorry.
when you convert it into S domain, T disappears completely. Either it should be cancelled out or you take the limit and you should get rid of it. Bella, are you doing anything?
Yes, I'm still working on it.
You're still working on it? Okay. So it shouldn't be that difficult because what you will do is here I show you the solution and please practice those when you go home. So basically what you are seeing is here, here it is. So, hold on. Okay. So all you do is you really make the ft is t. So instead of ft, you put its value, which is t, and then you have a limit t to infinity 0 to p t e power minus st. Now this is the integration. How you will do this integration? This is integration by
Parts.
how you
Like
will do
parts, right?
by parts. Very good. So you do integration by parts. You see, I told you that you should know your integration for Laplace transformation, and that is really very true. So integration by parts is the first function into the antiderivative of second function minus the derivative of first function into the antiderivative of the second function. So basically you are putting t multiplied by the integral of the second function minus the derivative of first function, which is 1, into the integral of the second function, and then you get 0 to p limit. Of course, when you will start putting p and 0 on the top, you will get e power st over s. So you will get p power, e power sp here, e power minus sp, and there should be another sign here. There is some typo here, you should be careful. So then you will get get this 0 to p, and you substitute upper and lower limits and simplify it, you will get this equation, and then you take p tends to infinity. Of course, wherever the p is, e power minus sp is e power minus infinity, which is 1 over e infinity, which is 1 over infinity, which is 0. Similarly, the third term will also be 0, and what is left is 1 over s squared. So it simply means that the Laplace of t is 1 over s squared. And not difficult, it is straightforward that you see what the function you are working with. Your function is f capital Ft. So that Ft will be substituted in this integral equation and you get your Laplace. All you have to do is to solve that particular integral. So that is another important, important example. Let me do another example for you. And
why does s have to be greater than 0?
so if it is so all these s are greater than 0, all positive values of s, you don't get negative values of s, because you will get infinity again. All these s's are greater than 0. So this is the condition for the condition when you will define basic definition of this, and you assume that s is greater than 0 there. So let me give you another example. Now I ask you to do a little bit difficult, which is e power here. So now you define your question is here. This is another question. So this is e power This is e power minus t, at. So this is your ft now. So please solve it. Please solve this.
What's the symbol between the E and the T?
Sorry, what is the symbol between a?
Okay.
A for apple, lowercase a, e power at. So again, you have to put this function here, e power at, and this is e power minus st. So e power st is e power st, then the powers will be added. So it will be e power minus st plus at. T will be common, and then it will be a minus s bracket t, and then you take the integral of that and apply the limits. So please do that.
Is it 1 over s minus a?
1 over s minus a, that seems correct. So what you do here then, give me 1 minute. What is the, hold on, sorry, I was just looking something else. So now you do it, the solution, and solution is here. Solution is here, that you have done exactly the way you did before, that you put, instead of ft, you put e power at, then as I said, you add them and they go, s minus a, 1 minus e, you take the derivative and integral, and then you put the lower and upper limit, you get 1 over s minus a. Of course, this is only valid when for make it positive, your s is always greater than a. So s will never be equal to a, because then it becomes 0. So 1 over 0 is infinity. So you don't do that. So s is greater than a. So this is the solution. So what is the outcome of this exercise today is that, number one, in order to do the control theory, you should know the Laplace. Why? Because then you can, it makes your life a lot easier. You, instead of solving the, the equations, you convert from the time domain into S domain, and in S domain you see, or whenever you get Laplace, you will get simple algebraic expressions. Then you can add them, you can multiply them, you can simplify them, and then you do inverse Laplace. So we have two steps. Step one, how to take Laplace from ft to fs. Second part, how to get the inverse Laplace from s to t. That is not difficult, but we need practice for that as well. So today, what I'm doing really is telling you how to take Laplace of a function, and it is very simple. You need to do this equation. You need to solve this equation, whatever your ft is. So I have given you several ft's. For example, I gave you ft equal to 1. I gave you ft is equal to t. I gave you ft is equal to et. And in each case, you get your very simple Laplace. In this case, you get 1 over s. If your ft is t, you get 1 over s square. If your Laplace is ft is e power at, you get 1 over s minus a. So this is all practice. You need to do a lot of practice of these Laplace, what you call, Laplace equations. Let me give you another equation, and it is really little harder. But I think that you should be able to do that. I give you another example. This is another example, and in this example, we are trying to find out the Laplace of sine at. Please do that. Very important. This is very important. So Laplace of sine at, please do that. you need to, you should know how to solve integral with sine and cosine when they are multiplied in product form. If you see your book, which is you are following, there are a couple of pages dedicated to Laplace, but and there are some assignments, which probably I'll give you some good assignment today to do it.
I'm getting -1/a, but I have no confidence in that being right.
Yeah, I don't think that's right. Maybe that's not right. Yeah, no, I think you're. Yeah, no, I don't think that's right. No,
I got S over S minus A.
no, that's also not right. But it is good. I'm very happy people are trying. Please try. So without a good hold over this Laplace, it will be very hard for you to really follow the. That's why I will give you today 10 questions as an assignment to do it and submit it. Allegra, are you anywhere near the solution?
Me?
Yes.
No, I'm still working on it.
Oh, okay, all right. Where is my eye here? Jacob, what is happening? Jacob, are you doing it?
Yeah, I'm still working.
So working on it? Okay. Where is this Mr. Upal? Upal or Upal? Upal, you are here, Rajan?
Yeah, I'm here. I'm still working on it too.
Oh, you are still working on it? Okay.
Yeah.
So there will be hyperbolic functions involved as well. So make sure that you revise hyperbolic functions. So, so any success or any revised answer?
I did the first integration by parts and am working
Yes.
on the second.
Okay, excellent, excellent. Okay. So the solution of this thing is here, and make sure that we understand that. So let me go over with you this solution. So here what we are trying to do is we are trying to do sine 80. So our ft is sine 80. When we substitute in the definition for Laplace, we get 0 to infinity integral e power minus st sine 80. Then we replace it by 0 to p, limit p tends to infinity. And the integrand doesn't change, it goes e minus st sine 80. Now you have to really do it integration by parts. And when you do integration by parts, remember that it will be better to take, you can take any one of them which is sine function. So take this first function, maybe sine 80, because its derivative will be cosine and derivative of cosine will be sine. So you have to do it twice. You have to do the integration by parts twice. And when you do integration by parts twice and you simplify it, you should get e power minus st minus s, this expression. And then the rest of the thing is very simple. You put 0 to p. So the most difficult part here is how to conduct. If you are not good in integration, then you should really practice this, because this is a very important This is a very important very important part, because you will have basically twice you have to do integration by parts. So you get first function sine at integral of second, which is e power minus st over minus s minus integral. Then you have the both of them. One is the integral, one is the derivative. That is again an integral. So you do another time the integration by parts, and then you separate and combine things, and you find the integral, this product integral, and that will be given by this. So there are 5 or 6 or 7 missing steps here which you should try and do it. So this is another example which will be used a lot. So sine at is a over s square plus a square. Okay, so I should ask one thing at least. Brendan, are you there? Brendan? Okay, Eric, shall we? Eric? I don't know why people are even not there, or maybe the system is Kyle Boardman, are you there?
Yeah, I'm here.
Yeah, okay. So if somebody gives you the Laplace of sine 9t, what will be your answer without solving it?
Would it be 9 over s squared plus 81?
81, yeah. So that's what you have to do if you apply directly the value. I give you another example, which is exactly the same as you are doing this one. And that example is basically, which is also very important. Let me go back here and get the snapshot here. Show that this. Here. So please find out the Laplace of cosine, which will be, procedure will be the same as the procedure you have adopted here, but then you have to really redo it. So I expect that everybody should be able to do sine alpha t. If you are at, if you are able to do sine at, you will be very easily can do cosine at as well.
Still working on sine of AT. Should I finish that
Okay,
first?
it's long. Yes, it's long. Yes. I lost my pen, then otherwise I would have helped you to do it. I don't know where my pen is gone. I should have here somewhere. Yeah, I unfortunately I have to purchase pen. I don't know where did I lose it. Oh, I think I lost it outside. I left it somewhere in the lab. All right, that's all right. So you do integration by parts twice. If you are unable to do it, probably I can do it next time, explain it on the board, but you should be able to do it. This is a linear algebra question. But this is the answer what they have given. For the cosine AT, I tell you now what answer you should get. Actually, you should get this answer. Similar answer what you have. So I should give you table, which is really a useful table for you. And these tables are available everywhere at the back of your book, Mathematics Linear Algebra book. Let me check this one. Here. So this table should be given, and this is the table which will help you to really remember here. So remember that your sine AT is a over s square plus a square, but cosine AT will be s over s square plus a square. So this is a and this is s. So make sure that you can check that. You can check that in your other books as well. So this is the value of cos AT, which is s over s square plus a square, while you have s sine AT is a over s square plus a square. So please do that and make sure that you are able to do this. Is anybody can share the screen, or anybody can share the image what they have done, or anybody has done sine AT?
I have, but it's on paper.
Oh, okay, but it is. Do you get a over s square plus a square?
Yes.
Okay. If this is the answer, then that's really great. Yeah. So similarly, you will do cosine AT and practice it. Now I tell you something. Let me save it and put it in your file. Hold on. So I will just say print. Let me print this file. I should make PDF. There is no PDF. PDF. I'm uploading this document for you for your reference, and so that you can go home and do it. So let's go to this. Spring 2021. So this is lecture April 5. Okay. So I will upload it. I'm uploading it now for you. I'm uploading it for you. So this is called lecture April 5. And I'm also uploading for you a okay, hold on. I'm also saving some practice questions for you. Let me share with you. Just give me 1 second. I'm uploading it on your file section. Where's the San Jose is gone? Oh, this is called string. Okay, so I will share with you now a practice questions. Please do these questions. So the first, can you see the screen? Can you see the screen?
Yeah.
Okay, so these are the questions where you have Laplace sine hyperbolic AT, Laplace of cosine hyperbolic AT. Answers are given, but you have to solve them and show them, and you have to prove these. Similarly, if ft is 5 when t is between 0 and 3 and 0 when t is greater than 0, then you have to solve it. Similarly, find the Laplace of 4 e power 5t 6t cube minus 3 sine 4t plus 2 cosine 2t. Remember that this is very important, that when you have expressions like these, you directly use the table. You do not need to prove the Laplace. You directly put the table. For example, sine 4t will be 4 over s square plus 16. Cosine 2 will be s over s square plus 4. So you have to do like that. You do not need really to prove them, but here you prove. The question, first question is really prove these things. The question 5, you really determine. Question 3, you substitute values. Question 4, you have to solve those. 1, 2, 3, 4 questions. But in the last part, you have a product e power at into cosine, e power at into sine. So you directly substitute those. And then there are some other questions as well. So these are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 11 questions, which will help you to understand how the Laplace is done. Okay, so this is called home assignment 4. I will upload it now for you so that you can do it, home assignment 4. So assignment plus called home assignment 4. Home assignment 4, and I will upload it. Upload document, submit, upload file. Home assignment. Submit. Home assignment 4. Okay, submit. So I have uploaded this. You submit your today and probably by Saturday or by Sunday is good. So you have more time. Submit it by Sunday. Okay, all right. So I save and publish. So please do that and make sure that you really practice these questions. If you don't practice these questions, then forget about the control section, because that cannot be done without your really understanding of Laplace and inverse Laplace. Okay, so we will start the theory next time when I meet, and we will do it on board. So on Thursday I will be there and I will be solving that question. Okay, so we have 39 students, 2 missing. That's okay. Okay, all right. So do you have any question for today's lecture? I have uploaded everything, so kindly do everything and make sure you practice. If you have questions, you can come on Thursday and ask me question, and I can help you to solve the problems if you are unable to solve it. Okay, all right.
Professor?
Hi,
Yeah.
Professor. Professor, can you reopen the project number 2 because I haven't done that. I missed that one.
Okay, we can do that. That's not a problem. Okay. What
Thank you
else?
so much.
Okay.
Professor, I had a quick question. unrelated to this class for 115 later today. Since this class was online, is 115 going to be online as well?
Yes, 115 will be online because there is the project you are doing doesn't need any hardware.
Okay, cool. Thank you.
Yeah, no hardware. And I sent email very clearly about it.
Oh, I don't think I saw an email. I did see a different section got an email.
Announcement. You should see announcement.
Yeah, we got the announcement on the Thursday section.
Oh,
I think,
it
yeah,
is
the
not for
wrong
today's
section might
section?
have got it.
Oh, okay. Let me recheck then. I think I sent it for today's section. Let me check it. Recheck
Thank
it.
you.
Yeah, no worries. Thank you.